Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Alright, good morning or good everyone. Good afternoon everyone. Depending on the time you are watching this video. In this class, we shall be looking at calculus, but an aspect of calculus called differentiation. Alright. Now, calculus is grouped into two. We have differentiation, we have integration. But our emphasis will be on differentiation. What do you understand by the word differentiation? Now, in simple terms, differentiation is simply a system or a process or a method of finding the slope of a function or the rate of change of a function with respect to another given function. The rate of change of a function, this rate of change can either be increasing or decreasing, but with respect to another variable or another function. So when you hear the word differentiation, what comes to your mind should be finding the slope of a function without necessarily plotting a graph. Alright? The general way of representing differentiation is called dy the what? Dy the x. It's called dy the x. Meaning the rate of change of y with respect to what? To x. The rate of change of y with respect to x. And we have different methods used in differentiation. We have what we call the power rule of differentiation. Number two, we have the first principle. We have the product rule. Number three, product rule. Number four, we have the quotient rule. Number five, we have the call function, also called the function and the function, also called the chain rule. We equally have what we call the implicit function. We have other aspects called the trigonometry function. Here we have sine function, cosine function. We equally have what we call the exponential. Alright. So the first rule we're going to look at is called the power rule of differentiation. For the power rule of differentiation, now the first rule is power rule, right? The power rule says if y equals to ax to the power of n, where y is called the dependent variable, x is called the independent variable, a is called the coefficient of x to the power of n here is called the exponent or the power rule says the y dx, meaning the rate of change of y with respect to what to x, right, is equals to multiply this power n with the coefficient of x and subtract 1 from the power. So that means that to find my dy dx from the power rule, n times a becomes na to the power of n minus 1. This is what the power rule is saying. Just multiply the power with the coefficient of this x, yeah, then subtract 1 from the power. A good example is example 1. If we have y equals to 2x to the power of 4, so the rate of change, the y will be, the rate of change will be 4 times 2 is 8, x to the power of 4 minus 1, which is equals to 8x to the power of 3. Now let's see another example. So let's look at example 2. For example 2, if y equals to 2x to the power of 6 plus 4x cubed plus 5x squared plus 4x plus 9, and we're asked to find the y dx. Okay, find the y dx, find the rate of change of y with respect to x. So in this case here, I'm going to differentiate each of these terms using the power rule of differentiation. Alright, so here we have here 6 times 2 will give us 12. 12x to the power of 5, right? Because 6 times 2 is what? 12. 6 minus 1 is what? 5. Then plus 3 times 4 is 12. 12x to the power of 2. 3 times 4 is 12. 3 minus 1 is 2. Plus 2 times 5 is 10. 10x to the power of 2 minus 1 is 1. But in mathematics, we don't really indicate 1 here. Already this shows that the power of x is what? Is 1. Then here we have plus. When you differentiate 4x, the answer is 4. When you differentiate 9, the answer is 0. Let me explain. I believe we all know how to find the first, second, and the third term. But for this, the power of x here is 1. When you multiply 1, let's look at 4x. Why did it say 4x is 4? The power of x here is 1. 1 times 4 is 4, right? X to the power of. The rule says always subtract 1 from the power. And that will give us 1 minus what? 1. Alright? And this will give us what here? 4x to the power of 0. And in mathematics, in English, anything raised to the power of 0 is 1. So this will give us 4 times 1. The answer becomes what here? 4. So that is why we say that whenever we differentiate 4x, the answer is 4. Or when you differentiate 5x, the answer will be 5. 6x, the answer is 6. 7x, the answer is what? 7. The same principle we use here is also applied there. But whenever you differentiate a constant value like 9, the answer, the derivative is what? Is 0. Okay. So I mean, the derivative of all constant value must amount to 0. Reason because if I have 9, if I'm saying that y is a function of x variables, the power of x here is 6. The power of x here is 3. The power of x here is 2. The power of x here is 1. There's a power of x here. The power is 0. So this is more like saying plus 9x to the power of what? 0. Because x to the power of 0 is what? 1. So 1 times 9 is what? Is 9. Okay. So that means that if I'm to differentiate 9, this is same as 9x to the power of what? 0. So by the time we differentiate this, I'll multiply this 0 by what? By 9. And whenever I multiply 0 by any number, the result becomes what? 0. So 0 times 9x to the power of 0 minus 1 is simply equals to what here? 0. So whenever we differentiate a constant value, the result must be equal to what? 0. Okay, let's look at this example. We are given that y equals to x squared, and we have to find the y dx using the first principle. We say we have 2 cardinal steps, right? The first step is to assume an increment or a little change in x and a little change in what? And y. An increment in x meaning we are adding a little change to what? To x. We're adding delta x to x, and we're adding delta y to what? To y. For me to increase x, I have to add a little change in x to x. For me to increase y, I have to add a little change in y to what? To y. So a little change in x is simply x plus delta x. For that of y is y plus what? Delta y. This is the first step, right? The first step in first principle means the first step says there must be an increment in x, an increment in what? In y. Increment in x means x plus delta x. Increment in y means y plus delta y. Then the second step is the step called the limit of a function, right? The limit of a function. Limit says that as delta x is approaching 0, delta y over delta x is we approach the y, the x. Meaning that as delta x is becoming 0, okay, in one side of the function, then delta y over delta x must approach the rate of change, which is the y, the what? The x. Please take note, these are the fundamental steps used in first principle, apart from the formula I gave. Now, if I have y equals to x squared, find the y, the x. Okay, solution to this is that we have to let there be an increase in x and y. Let there be an increase in x and y. That's the first step. Now, increase in x means I will replace my x with what? X plus delta x. Increase in y means I will replace my y with what? Y plus delta y. So anywhere I see y, I'll put this. X, I'll put this. Now let's go. Here becomes y plus delta y equals to 4x. That will give us x plus delta x all squared. Then I'm going to expand this here. By expanding y plus delta y, expanding this will give us x squared plus 2x delta x plus delta x squared. How do we expand this? It's very simple. Expanding this means I'll bring out this in 2 places. X plus delta x, x plus delta x. I'll multiply x by x, we have x squared. X times delta x is what? Is x delta x. Delta x times x is what? Is x delta x. Delta x and delta x is what? Is delta x squared. These two are like terms. Here becomes x squared plus 2x delta x plus delta x squared. So the expansion for this is simply this. Now the next is to I have to make my delta y as the subject of the formula, because the essence of doing that is to be able to generate delta y over delta x. So I'll look for a means to make my delta y to stand alone here as the subject of the formula. So here becomes delta y equals, what is the implication to that? It means I'll move y to the other side, and that will become minus y. Here we have s squared plus 2x delta x plus delta x squared minus y. So we're going to have here to be delta y equals to s squared plus 2x delta x plus delta x squared minus the value of y from the original function is what is y is s squared. So I will replace my y with what? S squared. S squared can cancel s squared. Here we have s squared minus s squared. The result is 1 0. They can cancel out. Then we are left with delta y equals to 2x delta x plus delta what? S squared. Now there is, after this, the next step is to look out for a means of generating this, because I have to take my limits, and to take limits I have to generate delta y over delta x. Now how do we generate that? Is by dividing through by delta x. I will divide through by delta x, meaning over delta x over what? Delta x over what? Delta x. If that should happen, this will cancel this, right? This will cancel one of these here. We are left with what here? Delta x. Now what do we have at the end of the day? Let's finish up. At the end of the day, we're going to have delta y over delta x equals 2x plus delta x. I can't stop here because I'm still having delta x here. So the next step is taking the limit, right? Limit of the function. The limit says as delta x approaches 0, delta y over delta x must approach the y to what? The x. What does that mean? It means that as delta x on this side of the function becomes 0, this must become what? The y dx. So let's go. Therefore, I will replace this with what? The y dx. So when this becomes the y dx, when this becomes turns to the y dx, delta x must become what? 0. That is what the limit talks about. It's all about. So this will give us equals to here 2x plus what? 0. Therefore, the y dx is equals to 2x. This is final answer. Now let's see another wonderful example. Next question says, find the y dx of this using first principle. We know the step. The first step is to increase y and increase x. Increase y means I will add y, I will replace y with what? Y plus delta y. Increasing x means I will replace x with x plus delta x. So here becomes y plus delta y equals to 2 in brackets x plus delta x plus 4 in brackets x plus delta x plus 7. I just replace my s with this, replace my s with this. Then here will be squared, right? Okay. Now let's go. Here we have y plus delta y equals 2. I've already expanded this in my first class, so I will expand this here. We have s squared plus 2x delta x plus delta x squared, right? So plus 4x plus delta x plus 7. Now let's move on. We have y plus delta y equals, we can expand this now. We have 2x squared plus 4x delta x. 2 times x squared is 2x squared. 2 times 2x delta x is 4x delta x. 2 times delta x squared is 2 delta x squared, right? Plus 4 times x is 4x. 4 times delta x is 4 delta x. Plus what? Plus 7. Now the next is to move this y to the other side. Here becomes delta y equals to 2x squared plus 4x delta x plus 2 delta x squared plus 4x plus 4 delta x plus 7 minus y. So what we have here, we have delta y equals to 2x squared plus 4x delta x plus 2 delta x squared plus 4x plus 4 delta x plus 7 minus y is given as this, right? Here becomes 2x squared plus 4x plus 7 minus y. Minus y meaning all these values here must be in brackets. The minus sign is affecting all of these terms here. So my delta y becomes 2x squared plus 4x delta x. Right? Okay. Plus 2 delta x squared plus 4x plus 4 delta x plus 7. I'm going to expand this here. It becomes minus 2x squared minus 4x minus 7. 2x squared, we subtract 2x squared. 2x squared minus 2x squared is 0. Right? 4x, we subtract what? 4x. Plus 7, we subtract minus 7. We are left with delta y equals to 4x delta x plus 2 delta x squared plus 4 delta x, right? Now the next step is to generate our delta y over delta x. I will divide through by delta x. So divide through by what? Delta x, delta x, delta x, delta x. So delta x, we cancel delta x from here. Delta x, we cancel delta x from here. One delta x, we cancel one delta x from here. We are left with one delta x. Now let's finish up this. Take note of this, take note of this. By the time we divide, we are left with what here? Here becomes 4x plus 2 delta x plus 4. 4x plus 2 delta x plus 4. Now let's finish up. By the time, the next is to take the limit, right? Limit of a function. Limit says as delta x is approaching 0, delta y over delta x must approach the y, the what? The x. So therefore, this expression will be turned to what? The y, the x, right? We have the y, the x becomes, here becomes what? 4x plus 2 times 0. I'm going to be replacing my delta x with 0, right? Then plus what here? Plus 4. And that will give us 4x plus 4. Final answer of this. Okay. Let's see another example. If I have y equals to 1 over x squared, find the y, the x. 1 over x squared, find the y, the x. Using the first principle method. The first principle. Solution to this. The first step is after increase y, also increase x, right? Increasing y means y plus delta y over 1 over x plus delta x all squared, right? Here becomes y plus delta y equals to 1 over, expanding this, I'm going to have x squared plus 2x delta x plus delta x squared, right? Okay, the next is to move this y to the other side. We have what here? Delta y equals 1 over x squared plus 2x delta x plus delta x squared minus y. But let me replace my y with 1 over x squared, right? Minus y is what? 1 over x squared. So yeah, I'm going to take the SCM in the denominator. The SCM between this and this is simply the product of the two functions, right? So here becomes x squared plus 2x delta x plus delta x squared times x squared. That's the LCM between these two denominators, okay? Now the next is to, I'll divide the whole of this, right? The whole of this with this. If I divide the whole of this with this will cancel this, remaining x squared. So x squared times 1 is simply what? X squared minus, divide the whole of this now with x squared. X squared will cancel x squared, remaining this. So the whole of this now times minus 1 will give us what? Minus x squared plus 2x delta x plus delta x squared, right? Okay, please don't forget, the first thing we did there was to move our y to the other side. And y is what? 1 over s squared. This is like saying minus y. Don't forget, minus y. I just went direct to replace my y with 1 over what? S squared, because it was given to us here. Then from here, we collected the LCM. The SM between this and this is simply their products. So the product of this means this times this. That gives us this. Then divide these two now with this. This we cancel the remaining this. So s squared times 1 is s squared. Divide this now. This LCM again with s squared. S squared, we cancel s squared. Remaining this. So this times minus 1 minus s squared. Minus sign is affect, we affect every terms here. So minus s squared plus 2s delta s squared delta s squared. By the time we expand this, we're going to be having delta y equals s squared minus s squared plus 2s minus 2s delta x minus delta s squared, all divided by s squared plus 2s delta x plus delta s squared times s squared, right? Now, s squared, we subtract s squared. We are left with delta y equals, these two we cancel and they will subtract themselves. We are left with minus 2x delta x minus delta s squared over s squared plus 2s delta x plus delta s squared times what? Times s squared. The next is to generate delta y over delta s. So I will divide both sides by delta x, which is what delta y over what? Delta x equals to minus 2s delta x minus delta s squared minus 2s delta x minus delta s squared divided by s squared plus 2s delta x plus 2s delta x plus delta s squared times s squared, all divided by delta x. What we did there is to divide both sides by delta x, meaning delta y over delta x, which is this, equals to the whole of this divided by what? By delta x. If I have this is also same as, if I have divided by delta x, this is also same as times 1 over delta x. If we have division sign here, and I remove it and put multiplication, it means I will inverse that function, right? So from here, delta s, we cancel delta s from here. Delta s, we also cancel what? 1 delta s from here. Let me explain something. In mathematics, I have a plus b, let's say over 1 times 1 over c. A plus b over 1 is like this, Abi, times 1 over c is like this. This c will be affected by both a and what? And b. The expression for this becomes 1 over c times a give us what? A over c plus what? B over what? C. Meaning that if I'm to multiply the whole of this now with 1 over delta s will divide what? 2 minus 2s delta s, Abi. Delta s will also divide minus delta s squared, because from this expression here, this will affect both this and this. Do you get the concept here? So while evaluating this, I will not multiply this with this. I'll just go ahead and divide with this and this. Is that clear? Okay. So by division, by the time this, we cancel this from here. Also cancel one of this from here. We have what left? We have 1 delta s remaining. Here becomes delta y over delta s becomes minus 2x. Okay? Minus 2x minus delta x divided by s squared plus 2s delta x plus delta s squared, right? All multiply with s squared. Okay. Then at this point, I can take my limits. Limit says as delta x approaches 0, delta y over delta x must approach divide the what? The x. So let's go. Let's take our limits. So here becomes divide the x. Minus 2x minus 0 over what? S squared plus 2x squared. Sorry, this is 2x, not 2x squared. 2x delta s, meaning 2x times 0 plus 0 squared times s squared. So this will give us delta y over delta x equals to minus 2x divided by s squared times s squared. This will give us, because 2x times 0 is off. 0 squared is also off. We are left with s squared times s squared, right? Here will give us minus 2x over s to the power of 4. S squared times s squared will give us s to the power of 4. Therefore, divide the what? The s becomes what here? One of these x here, we cancel one of these s from here. Here we have minus 2 divided by s to the power of 3. This is s times s times s times s in 4 places. Here we have just one s. So one of these s we cancel one from here. That will give us this. So this is our final answer. Alright? Or we can also express this as minus 2x to the power of minus 3. Either this or this. We are correct. Okay. We have a question that says, given that y equals to square root of x, find the y dx using the first principle, right? General method for this, or power rule rather, power rule for this is that this can be expressed as s to the power of half, right? To the power of half. So by using the power rule, the y dx, that will give us half. Half times 1 is half, abi? Subtract 1 minus half minus 1, right? This will give us the y dx equals to half x to the power of what? Minus half. So by the use of power rule, this should be our final answer. This should be our final answer, right? Which is same as 1 over 2x to the power of what? Of half. Okay, so by the power rule, I will have to express this first, bringing on the power of x. Then apply the power rule of differentiation. It's either you have this or you have this as your final answer. But let's see what we're going to have using first principle. The first thing, we have to increase x and also increase y. We have y plus delta y equals to square root of what? S plus what? Delta x. The same thing, the same principle. So I'll move my y to the other side. Here we have delta y equals to square root of what? S plus delta x minus y. Minus y. This will give us what here? Delta y equals root of s plus delta x minus our y is with x. Now the next step is to divide through or divide both sides by what? Delta x. Divide both sides by delta x. That will give us delta x is over what? Delta x. Let me bring out the pen here. Divide both sides by delta x. So we have delta y over delta x equals to root of s plus delta x minus with x all over what? Delta x. When you come to this aspect of implicit function, the next step to take is not just by taking limits. I can't take my limits here. If I take limits here, I will end up having 0. Imagine if I take limit and put 0 here. Here will be with s minus with x. I'll be having 0 there, right? At the end of the day, the answer was 0. Exactly. But what I have to do is I have to rationalize the numerator. I have to rationalize the numerator. The numerator. By multiplying the conjugate of the numerator with the numerator and the denominator. The conjugate of a sum in mathematics, if I have a sum, sum A plus sum B. The conjugate of sum A plus sum B is simply sum A minus what? Sum B. The conjugate of sum A minus sum B is simply sum A plus sum B. Conjugate simply means just change the sign that is found between the two sum. If the sign is plus here, the conjugate of B becomes what? Minus. Right? And by the time we multiply the conjugate of two sum, if I multiply these two conjugates, I'll be having what we call a real number. A real number. Okay? Now, what I mean by this is that let's multiply and see. Let's multiply these two together. Sum A plus sum B times sum A minus what? Sum B. Sum A times sum A is A, right? Sum A times sum A is A, and that will give us sum A squared, right? Plus sum A times minus sum B is minus sum AB. Sum B times sum A give us what? Plus what? Sum what? AB. Sum B times minus sum B give us minus sum what? B squared. Square can cancel square root. This can cancel this and B. We are left with what here? A minus with AB plus with AB is 0. This will disappear. We are left with what here? A minus B. So anytime we multiply conjugates with each other, just like this, the expression is always a real number. Alright? Or a number without a sign. Right there? So for this, if I'm to multiply the conjugate of this with this, if I multiply conjugate of this, which is x plus beta x minus with x with x plus beta x plus with x together. The conjugate of this is this. Conjugate of this is this. So multiplying both of them together, this becomes my A. This becomes my B. Multiplying this with this. Here I have what here? I have my A here, I have my B here. So I'll just say A minus B. Anytime. If I have this, if I'm to multiply with x, let's say with x minus with y with x plus with y. These two, they are conjugates. The result must be x minus y. Meaning I'll just pick the first alphabet here, which is x, then subtract from the second one. You get the concept? That's how to find conjugates. Now, for this expression, multiplying this with this, that means this becomes x plus delta x minus x. That will be the result. The reason why I have to show you this process is that I don't want to start expanding. There's no time. In the exam or in any exam, just apply this principle. You are good to go. So for this now, we have seen that to actually rationalize means I will multiply the conjugate of the numerator with the numerator itself and the denominator. That means my delta y over delta x becomes square root of x plus delta x minus root what? X, all divided by delta x. Then times the conjugate of this, right, will give us what? Root x plus delta x plus root x divided by what again? Root x plus delta x plus what? Root x. Look at this here. This is what we mean by rationalization. To rationalize the numerator means I'll multiply the numerator and denominator by the conjugate of the numerator. This is only possible in first principle. In normal sum, we rationalize the denominator. But when it comes to differentiation under first principle, we have to rationalize the numerator. That is just the principle. So, meaning multiply this and this with conjugate of this, which is this and this. Now, we have seen that multiplying the numerator, these two, they are conjugates. These two are actually conjugates. So, when you multiply the whole of this here with the whole of this, the result becomes what? Delta y over delta x becomes x plus delta x, right? Minus what? Minus x. Don't forget. I will subtract this minus this. That's the result. When you multiply the whole of this here with the whole of this. So by multiplying these two, the result will give us this. Then divided by, here we have delta x in bracket. Delta x is multiplying everything here. That will give us root s plus delta x plus what? Plus root x. Okay, s minus s we cancel out, right? If these two should cancel out, what remains here is what? Delta x. This same delta x here, we cancel out with what? With this delta x here. Then we are left with delta y over delta x equals to 1 divided by square root of s plus delta x plus what? With x. Then at this point, I will then take my limits that says that as delta x approaches 0, delta y over delta x must approach the y dx. So that means that here becomes my dy over the x becomes what? 1 divided by root x plus 0 plus root x. And that will give us 1 over root x plus what? Root x. By the time we evaluate further, this will give us 1 over root x plus root x will give us 2 root x. If two surds have a common base, they can be added together. Just add up their coefficient. Coefficient of this surd here is 1. Here was 1. So 1 plus 1 is what? Is 2. Here becomes 2 surd what? X as the final answer. This can also be expressed as 1 over 2x to the power of 1 of half. This can also be expressed as this. Or you can leave your answer in this form. Okay.